Hello everyone, welcome to EV201 Capstone project presentation. I am Chetan Agroya and today I am going to show and explain working of EV powertrain prototype made by me. So starting with it, this is the project I have made to demonstrate how does a EV powertrain works. It contains different components which work together like motor controller, battery pack, battery monitoring system. Let's start with the motor. As you can see, this is a simple BLDC motor. It contains 3 coils 1, 2 and 3 and 2 permanent magnets which are 1 and 2. It also contains a bearing to which the magnets are connected. The energizing coils are made from copper wire of 22 AWG with a soft iron core bolt. The working of motor is such that when you energize a coil, the magnet will attract to it and it will rotate. When you energize next coil, the magnet will again attract and rotate. And when you keep on switching, the magnet will keep on rotating. So, to make the motor rotate by itself, we need to keep on switching the coils. Now, let's come to motor controller. As you can see, this is a simple circuit which contains MOSFETs, resistor, and Arduino. As we saw in the motor, we need to keep on switching the coils. The process of switching the coils is done by this motor controller. The working of circuit is such that when Arduino sends a signal to MOSFET, the MOSFET acts as a switch and allows the power to run through this line, which is then connected to the separate coils. The Arduino is programmed such that it will keep on switching these three MOSFETs one by one. That is, the power will go through the coils one by one and the rotor will start rotate. Now let's go towards battery pack. As you can see, this battery pack contains 4 individual cells and it also contains a temperature sensor to monitor temperature. The battery pack is then connected to BMS. The BMS monitors temperature and voltage of the battery pack. The circuit of BMS contains two parts, a voltage divider circuit to step down voltage and an Arduino. The wire from separate cells in battery pack are connected to the analog pins of Arduino, and the wires of temperature sensor are also connected to Arduino to monitor temperature and voltage. While in use, the BMS constantly monitors temperature and voltage of the battery pack and decides what power should be supplied to the motor. When BMS decides what power is to be supplied to the motor, it then communicates with the motor controller via I2C communication, which is a serial communication. The I2C communication line contains three wires, a ground wire, a data wire, and a clock wire, which are connected to both the Arduinos. In the communication, the BMS Arduino acts as master while the motor controller Arduino acts as slave, which means the BMS Arduino can send the data while the motor controller can receive the data. When motor controller receives the data, it sets the delay between the switching of the MOSFETs according to the power available. The delay directly refers to the RPM of the motor. Now we will see different components of this system working together.